This video is going to cover our first part of Chapter 1, Points, Lines, and Planes. We're going to focus on two things, defining congruency, and that you can just name a point, line, plane, segments, and rays. So 5 different things. They look very, very similar as far as notation, but they are very, very distinct things. And the symbols that we use actually are reminiscent of what it looks like. So use those symbols to help guide you when you are doing this naming. So to start with, this, you can just see it on the screen. I can't really describe it because you don't know all the names of the parts yet. But it is the symbol that stands for is congruent or congruency, right? And congruent means something has the same shape and size. So notice the symbol for equality is embedded in this symbol. The bottom half of this symbol is the equal sign, and that's where the same size and same shape come from. Particularly the same size is the equality piece. The congruency, the squiggly at the top, actually is the symbol for similar, which is more the same shape. So the equality is the same size. The little similarity squiggle at the top is the same shape. And we combine both of those for congruency. And so when we have a geometric drawing, like the 2 trapezoids that you see below, when we have identical tick or arc marks, those are going to indicate congruent segments or angles. And that just means that these segments and angles have equal measures, segments being the same length, angles having the same angle measure. So when we talk about tick marks, we are talking little bitty lines that through. If you have more than one set, they're going to have a different number of tick marks because you can see that those sides that are marked are different side lengths. And since the lengths are different, it's a different pair of tick marks. But when you have that pair, they are the same length. And then the same is true with arc marks. We can see that those are acute angles, and we have been told because of the arc marks that they are the same measure. And then again, because we have 2 arc marks instead of 1, these 2 are also congruent, but they are not the same as the first one. So count the arc marks, count the tick marks. They have to be identical in order for us to have congruent segments or angles. They do not have to be in 2 different figures. They could be in the exact same one. If you think about like a square, all the sides are the same. So we would have 4 single tick marks on a square. So we also are going to really focus in on this unit on points, lines, and planes. And one of the interesting things about geometry, we prove an awful lot in geometry, but these words, point, line, and plane, are technically undefined. We just have to come to an agreement on what we mean when we refer to them, and that's exactly what we're doing. This is what we mean, but officially in geometry, they're considered undefined. And we say that because when we use them, we in geometry are always proving things, and we can't prove the very foundational things. They're just the things that we have to agree exist. And that's kind of what we're talking about. These are existence concepts. And the point, weirdly enough, has no dimension. Even though we can see it, it does not have any dimension at all. And it is just named using a capital letter. There is no symbol that we use for a point. When we see it on a page, it's a point, and there is a label next to it. And we will say point A, but a lot of times we will just use that letter A. It depends on context. If you have enough information that to reference it, it can just be the letter, but often we put the word point in front of it because letters of the alphabet are used for so many different things. But points are always capitalized. When we look at a line, however, the line, this may also be counterintuitive, extends in one dimension. We always have 2 arrows on a line, but it is actually one-dimensional. And it is named using a single lowercase I cursive letter like you can see the little L over here underneath the C, or by 2 points that are on the line. The symbol that we use is a double-ended arrow, and it always appears above those letters. When we're using the cursive letter, we do not use that line. We just literally use the cursive letter. Sometimes we'll put the word line in front of it, but not always. And so we can do any 2 points on this line. So I can do AB, I can do AC, I can do BC. I can reverse the order on any of those as well. But every one of them will have double-ended arrows because the line goes forever in both directions. And that's what those arrows are indicating. When we consider the plane, how many dimensions? We're going from 0, 1, and now we have 2 dimensions. And it is named using a single uppercase cursive letter. You can see that little M in the corner, or by 3 non-collinear points in the plane. I'm going to define non-collinear in just a minute. There is no symbol for plane as well. We have to put the word in front of it. So plane M or plane ABC. And we can name any of the 3 points. We could have done BCD, ACD, just pick any of the 3, DAB. I mean, it doesn't really matter which 3 points you use or what order you use them in, as long as you name 3 of them. It takes, because it's 2-dimensional, we have to have 3 points to define it. Notice that we always have 1 extra point for the number of dimensions. And I'm going to go ahead and finish up here with our collinear points. They are points that lie on the, before I get to that, I do want to talk about the word co. Co just means together or joint, okay? And that's an English prefix. So when we see the word collinear, coplanar, that means that they are together. So I'm blanking on another word that you would actually know, but it's kind of like companion, that that's someone who lives together. So anyway, collinear points are points that lie on the same line. You can see the word line in the middle of linear. Even though we don't call it linear, it is linear. And coplanar points, you can kind of see the word plane hidden in the middle of that, are points that lie on the same plane. And if you look in your table that I don't have showing on the screen right now, points A, B, and C are collinear. They are all 3 on the same line. When we talk about coplanar, that last one, points A, B, C, and D are all coplanar. When we talk about collinear and coplanar, there is not a minimum or a maximum number of points that we can name. It's just the relationship that exists between any 2 points. So while I'm listing 3 or 4, it does not matter. Okay. Now, 2 points are enough to make a line. And so as long as I name 2 points, I'm going to have a line. But I may see a line that a 3rd point is not on. And so in which case, it's not considered collinear with those points. Often we will talk about 3 points for collinear, and we will talk about 4 points for coplanar. Now, intersecting lines, I hope you already know, they are just lines that cross one another. I'm going to go ahead and give you just a really quick picture, just more of a sketch. So just be aware of what those things look like.